Hi guys, and welcome to your lesson for section 1.7, Transformations in Geometry. Transformations in the coordinate plane. Sorry, Missy McCarthy, Oakman's High School math instructor. Alright, so let's take a look at one of the more important topics, I would think, in geometry that translates to other areas of mathematics as well, and especially into the arts, and that is the transformation. So you can see here the definition of a transformation, which is a change in position, size, or shape of a figure. The original figure, which would be this one here, triangle ABC in this instance, is called the pre-image. It's what you have before you make any changes, before you do any transforming. And then the resulting image, which is what you see down here, is called the image. The transformation maps the pre-image directly onto an image, and we can write that using arrow notation. So you can see here for the pre-image is triangle ABC, and we use our arrow, which says that maps directly onto triangle A prime, B prime, C prime. So A matches up with A prime, B matches up with B prime, and C matches up with C prime. There are three types of transformations that we're going to deal with. We're not going to deal with changes in size right now. We're only going to deal with changes in position and orientation. So those three transformations are the reflection, otherwise known as the flip, where all points maintain the same distance from a line of reflection, a rotation, also known as a turn, where all points maintain the same distance from a point of rotation, and a translation, also known as a slide, where all the points move in the same direction, the exact same distance.
Have you ever seen a real live dinosaur or dragon? You haven't, because scientists have determined that dinosaurs lived millions of years ago. And you know that dragons only flared their nostrils and breathed fire in fairy tales. But that doesn't stop animators from trying to bring both creatures to life on film. Using computer animation and motion geometry, artists take dinosaurs and dragons from science and fiction to the screen.
Go behind the scenes to see how the biggest special in Animal Planet history was created.
They transform geometric shapes using translations or slides, moving a shape from one location to another without changing its orientation, size, or shape. Rotations or turns, making the figure rotate about a single point or axis along a circle. And reflections or flips, reflecting one shape to the other side to produce its mirror image. These transformations help artists build the creatures on screen with depth and the sense of motion, making the animals and their worlds look real.
That we've seen how it's used in movies, let's try a few examples. Identify the transformation, then use an arrow to use arrow notation to describe the transformation. So here, if we look at our image, our pre-image, which is ABC, triangle ABC, and our image, triangle A prime, B prime, C prime, we can see that to get from this image to this image, we would have had to take this triangle and rotate it. Because side AB is here, and its image, A prime, B prime is here, you could have gotten that any other way than to rotate it down. So we would then just say that triangle A, B, C maps onto its image, triangle A prime, B prime, C prime. And here, when I first look, I think, wait a minute, this could be a translation. Maybe we just took this rectangle, EFGH, and slid it down. So I see if that's the case, but I look here, if I were to take this blue one and slide it down, then E would be on top of F prime, and F would be on top of E prime. D would be on top of G prime, and G would be on top of D prime. That tells me that it's not a oops, forgot to write rotation here. Said it but didn't write it. That tells me that this is not a translation. However, it is a reflection. And if we were to write that, we could say that rectangle EF, oh, I guess I could do DEGF, DE or FG, that works as well. Maps onto DEFG, maps onto rectangle D prime, E prime, F prime, and, oh my word, yes, G prime. I'm getting this right. Okay, so that's a reflection. All right, let's see about our next example. It says a figure here has vertices A, which is at 1, 1, so I'm going to plot that, or 1, negative 1, shall I say? So I'm going to plot that. And then B, which is at 2, 3, plot that there. I'm going to call that B, call this A. And C, which is at 4, negative 2. So there's C. So I have my triangle here. And it says, after a transformation, the image vertices are at negative 1, negative 1. So that would be A prime. At negative 2, 3. So this would be B prime. And at negative 4, negative 2. So that would be C prime. So if we look here, what happened to the image? We have to draw the pre-image, which we did, ABC, and the image, A prime, B prime, C prime, and then we have to identify the transformation, and this to me appears to be a reflection. Now you can also do translations in the coordinate plane without drawing the image. And again, this is just for translations right at the moment. Without drawing the image and the pre-image and the image. And we can simply use what we call this rule that takes any point xy and it maps it onto any point x plus a and y plus b. This plus a will just slide x left and right, or I'm going to say left or right. And then this adding b, or it could be minus a number, will just slide the y value or slide the image point up or down. And that will give us a slide or a translation. So if we look here, it says use this to find the image of ABC. So all of our points x are going to become x plus 2. All of our points y are going to become y minus 1. So if I look at the current coordinates, the coordinates of A are negative 4, 2. The coordinates of B are negative 3, 4. And the coordinates of C are negative 1, 1. Now, under this translation, all of the points are supposed to go from xy to x plus 2 and y minus 1. So when I find A prime, I need to add 2 to negative 4, and that gives me negative 2, and subtract 1 from the 2. So that gives me 1. B prime, I'm going to do the same thing. Negative 3 plus 2 is negative 1, and 4 minus 1 is 3. And then C prime, negative 1 plus 2 is 1, and 1 minus 1 is 0. So if I plot my new points, let me try to get a different color. I have negative 2, 1, so there's my new point A. And then I have negative 1, 3. There's my new B, my B prime. And then I have 1, 0. And that's my C prime. And if we draw this here, this is A prime, this is B prime, and this is C prime. You can see that this image from the pre-image has been slid to the right 2 and down 1.